थोड़ा इम्पोर्टेंट बोलता हूँ उसका मतलब दोस्तों में, ठीक है।
थर्ड अंपायर
So, we'll discuss the landing gear, doors, nozzle steering, anti-skid and brake. But just rebrushing you because you are going through the extended recurve. It is not an endorsement where we'll discuss everything. Well, some of the sections will be covering. So basically, landing gear, two main landing gears, one nose landing gear. The doors, that includes gear base, gear doors are electrically controlled and hydraulically operated. All gear doors open while the gear is retracting or extending. There are two LGCIUs, landing gear control and interface units, which supplies, both supplies to the panel and one supplies to the ECAM. Which one supplies to the panel? If LGCI one fails, then also? If it is electrically supplied, then it will show. LGCI panel, if it is LGCI one fail, still if it is electrically supplied, still it will show. Otherwise, LGCI one. And switchover happens, LGCI 1 to 2 are not.
No.
What are the cases? One cycle basically. When you extended and retracted. So one cycle, so automatically it will switch over to the next other computer. Or in case of a failure. Or sometimes we do recycling. Up and down. So it's recycling, so basically it switch over the LGCI 1 to 2 to 1. Tool and LGCIU control the extension and retraction of the gear. They also supply information about the landing gear to ECAM for display and send signals indicating whether the aircraft is in flight or in ground to the other aircraft system. The LGCIU is very important because it gives you information to EIU, to FedEx, so the FedEx will come to know what is the condition of the flight, whether I am in ground or in air. So based on the requirement, we do rest of it. So LGCIU send the information to the other aircraft systems also. There is a hand crank or manual or gravity extension also. So main landing gear, nose landing gear. So landing gear, LGCIU information from landing gear, cargo door and landing flap system. So there are proximity detectors. In the LGCIU there are proximity detectors. So they gives the information when the landing gear are locked down, so are down, locked. Shock absorbers are compressed or extended. Landing gear doors are open or closed. Bogies are lined up. Cargo door. So it receives information from the sensor, the manual, selector wall, locking saw, locking handle, safety saw. Even flaps and slats information with the proximity switches are there. They send to SFCC information to the slab flag control computers. The LGCIU do not monitor failures in the SFCC. If any failure is there in SFCC, LGCIU doesn't have any control there. Two LGCIU are there, 1 and 2. Basically, one LGCIU controls complete gear cycle and switches automatically to the next one. In case of failure also, it switches. Then there for gravity extension also. Normal operation. The flight crew normally operates the landing gear by means of the lever on the central instrument panel. So there is a lever on the central instrument panel. So LGCIU controls the same thing I have written again. One LGCIU for the complete cycle, and then in the next cycle it will switch over, or in case of failure. There is a green hydraulic system which is supplying to the landing gear. So it controls both the gears and doors. So when the aircraft is flying faster than 360 knots, a safety valve will be there which will be automatically closed or cut off hydraulic supply. So if it is the speed is more than 260 knots, it will automatically cut off in landing gear system, the hydraulic supply, basically hydraulic systems. Below 260 knot, the hydraulic supply remains cut off as long as the landing gear lever is up. If your lever is up, the information is going that the lever is up, then also the supply will cut off. So this is the basic diagram. If you see, there is a hydraulic system which basically controls the landing gear. The landing gear, basically there are two things. One is the doors, other is the landing gear. Then uplock assembly also there. Inside that uplock assembly is there. So there is a OR gate, two OR gate, either ADR1 or ADR3. Hello. नमस्कार नमस्कार। केवल चाय आपकी आई थी, आप नहीं आए थे। आपको अब्सेंट मार्क किया था। ऊपर आया। अच्छा ठीक है, साइन करेंगे। ओके। जल्दी मेरी क्लास थी, क्लास में भाई ब्रेक में ही आया, ब्रेक में। Okay. So ADR1 and ADR3, it gives you the speed information whenever it is less than 260. And the first OR gate, there are three information, either ADR1 or ADR3 or main landing gear is on ground. Second OR gate is that the lever is down. So one input from both, it is going, there is a AND gate. This will now give the direction to this safety valve to open. So when we are meeting the requirement, when all the requirements are met, so it opens the safety valve. When the safety valve is open, green pressure, green hydraulic system will activate this. So when it is activated, first it will go to the door selector valve. First the information will go to the door selector valve, it will open the door. Again with the proximity sensor, the information, the GCIs are there, the information is going there, so it controls the now the gear selector. Uplock assembly it will open, then the gears will be down. Again the information will go to the door selector and the doors will be closed. This is how the landing gear. Same process will be in case you have to retract the landing gear. So first what will happen? Landing gear is already extended, the doors will be open. Second step, the doors will go up and the uplock assembly will be there, and then the doors will be. We can both LGCI 1 and 2 to give you the information. Then the landing gear position and all the information. Where indicator pattern, only LGCI 1. Even if it is electrically supplied, still the information will be. Now one important one. If suppose yellow and blue system, low pressure. So can we do a normal landing gear extension?
No, sir.
Why?
To maintain integrity of the green system.
So basically, we don't want to lose the integrity of system, isn't it or not? Landing gears are also a high-end user. So only one system is available, and that if you are going to utilize for this operation, so that could create a problem. So that is where there is a cut-off wall. Sometimes the information goes over there, it cuts off. So basically it's isolated. Now there is no hydraulic system, so there is no scope that this landing gear will work. बीच में कुछ आवाजें आती मुझे, अगर मैं भी पीछे आ जाता हूँ, अगर कुछ डिस्कशन हो रहा है तो मुझे भी कुछ सीखने को मिलेगा। हाँ, फिर हम डिस्कशन ही करते हैं, छोड़ देते हैं। क्वेश्चन है, बोलिए। If you have to discuss among yourself, I'll be sitting also with you people to discuss those things. So in gravity extension, कितने 5 times rotate करते हैं? 3 times. The normal system fails, extend the landing gear hydraulically or anti-clockwise. So when the crew member turns the crank, so what the first step what it happens, isolate the landing gear hydraulics from the green hydraulic. That cut off wall absolutely done. So it will cut off that wall. So now there is no scope, there will be no hydraulic pressure, so there is no possibility that through that channel the landing gear will be active. So first step, it is isolating the hydraulics. Second is unlock the landing gear doors and main and nose main gear. So it is unlocking all the things. Whatever the unlocking mechanism is there, that is good. Third step allows gravity to drop the gear into the extended position. Now in the extended position itself, the gear will be down. Now when the gear is down, it has to be locked. So there is a locking spring for the main landing gear, which is keep it in lock position. Whereas for nose landing gear, aerodynamic force. The aerodynamic force is keeping it in. This is the panel. The light comes green when the gear is locked down. Unlock light comes on red if the gear is not locked in the selected position. The panel is connected to the LGCI 1 only. Therefore, the lights on the landing gear panel indicates comes on as long as LGCI 1 is electrically supplied. Camera triangle, green triangle indicates landing gear down low. Red triangles, landing gear in transit. No triangles, detects a landing gear up low. Amber crosses will replace the right triangle to indicate the LGCI 1 or 2 as state. Uplock. This is somewhat important. So लोगों भी काम खड़े हो डायरेक्ट उस पे ही जाते हैं क्या होता है वैसे आप बता दो गियर अपलॉक फॉल्ट ये क्या होता है क्या होता है व्हाट डू यू अंडरस्टैंड बाय गियर अपलॉक फॉल्ट
It is unable to be locked up.
ये तो थोड़ा इंटरेस्टिंग इस तरह दिखा This alert triggers when one gear uplock is engaged with corresponding gear downlock. So basically, upside there inside the assembly, there is a uplock assembly, there uplock mechanism, locking mechanism is there. Your gear is down and it is locked. But that mechanism, uplock assembly mechanism is also locked over there. So by chance, if you try to retract the landing gear, it is going to hit that uplock assembly. And the damages will happen. There is a possibility that it is going to damage the landing gear. So that is the landing gear uplock fault. It triggers when one gear is uplocked. So this uplock assembly is engaged while the corresponding gear is down. The gear is down and it is locked. Whereas in assembly section, uplock assembly is engaged. So what is the action? Landing gear, keep it down. Why? If you try to retract, it is going to hit and damage the landing gear. The landing gear must be left down to avoid any structural damage. Because the uplock device will stay in the lock position. This is the reason why the Airbus is recommending don't retract the landing gear because it is going to do the structural damage. Then max speed and other things. And some of the times you will see landing distance procedures apply. So it happens your landing distance is going to be revised. When your landing distance is going to be revised, some of the cases you may have to make a go around. Because you have already calculated something that is not holding you good. Isn't it or not? Yes. Then you have to do again the entire calculation. So for that you need some time. So you make a go around and by the time you will come, you will calculate. Sorry. This matches triggers same thing. When the failure affects the normal aerodynamic characteristics of the aircraft, if the flight continues to destination or alternate with landing gear extended, disregard FMS fuel consumption because the fuel consumption is going to increase up to 180%. In order to find the applicable FS fuel penalty factor, disregard FMS altitude and speed to 6. Your gear is still down. So that prediction will also not hold good. So that you have to disregard. Do not use the managed speed and do not use the climb and descent autopilot. So all those information will not be correct. So that's why they have recommended to disregard. Then there is a gear not uplock. ये कौन सी condition है? When your lever position. This alert triggers when one gear is not up locked and landing gear is not selected down. If the landing gear sequence is not completed after 30 seconds, lever is selected. I'll go to same page. Why? I'll go here. The alert triggers when this T4 important means out of 3 or 4 one question will come. Okay? Because I'm not sure which question will come, but yes, these are the some of the questions that we'll discuss, and among that questions, one of the questions will be okay. Landing gear not uplocked. So this alert when triggers when gear is not uplocked, so gear is not gone uplocked properly, and landing gear is not selected now. Landing gear you have not selected down, so it is not in transit position. Basically, if you have selected it down, maybe in transit position there is a possibility. But this is if you have not put it down, so there is no transit condition, and there is no the gear is not uplocked properly. So that's why this alert triggers. Then, so the recommended the warning appears if the landing gear sequence is not completed after 30 seconds. If the proper sequence is not completed after 30 seconds, this warning will come. So landing gear doors closed, devise access G factors because the gear rests on the doors. Avoid excessive load factor in order to not damage load responses. So basically, if any fluctuation, try to maintain the level flight. If it is level flight, less load will be there. If the fluctuations are there, there will be a possibility of structural damage. Landing gear doors not closed at shock absorber fault, so then they have restricted the speed. Landing gear has to be down, max speed is matched. If the shock absorber and no shock absorber fault, then you may process the recycling of landing. What is the purpose of recycling? Any purpose? So basically, in case one of the computer has failed or it is not working properly, the moment you recycle, switch over will take place from LGCI 1 to 2 or 2 to 1, whatever is working, the next will be start working. So there is a possibility by switching over the computers, the system will start working properly. To recycle the landing gear, flight crew must perform the following action. How you will do the recycling? Move the landing gear lever down. So you will be putting the lever down, wait for the landing gear to downlock and for landing gear doors to close. So if everything is working proper, your gear will be come down and it will be downlocked. Isn't it or not? Simultaneously monitor the wheel page on the system display. Then move the lever up. The active LGCI changes when the landing gear is recycled. If it is recycled, working fine, that's okay. If unsuccessful, if it is unsuccessful, then we'll have to keep the landing gear down only. Then the speed restriction to this one. Fuel consumption will increase accordingly, so you have to take yes, my fuel consumption will be there. And then again the same things, whatever we discuss, all the predictions has to be discussed. One is gear not down lock. So far we discussed gear not up lock, gear not down lock. This alert triggers when one gear is not down locked and landing gear is selected. We have selected the down, but the message is not coming that it is down and down. This warning appears if landing gear sequence is not completed after 30 seconds. So here straight away we do the recycling. Since we are interested to putting the landing gear down, isn't it or not?
Yes.
But since the action is not completed, so we'll try to do the recycling. In the recycling process, again the same procedure. Take the lever down, let the gear down, lock, and then putting the lever up, it will go up and doors will close. So this will change the LGCI switchover. If unsuccessful after 120 seconds, so then you have to wait for 2 minutes. After doing the recycling in this case, you have to wait for 2 minutes. Landing gear gravity extension. Now some problem is there because our interest is to put the landing gear down, and it is not possible to automatically the landing gear will extend. Then we will try to do gravity extension. We go 5 times anti-clockwise. Yes, 3 times. सोते हुए लोग जग जाते हैं इसलिए वो बोलते हैं. ठीक है. Rotate the handle clockwise about 3 turns until reaching the mechanical stop. Why it is saying the mechanical stop? Because sometimes because of friction, some dust and other things, there is a possibility you will feel some resistance. Still you have to complete that. Then comes the landing gear gravity extensions. So, one we discussed about the landing gear not down lock, alert when displayed and if time permits. The landing gear recycling can be attempted up to 4 times. So that recycling also there is a number of attempts. We cannot do for a number of times, 10 times, 20 times. Only 4 times. The Airbus recommends that only 4 times if necessary, that too if necessary. These additional attempts should enable the successful pressurized extension of the landing gear and avoid a landing gear extension by gravity. So that's why they have restricted that you go for up to maximum attempt of 4 times. Then landing gear lever up, wait, landing gear up lock, lever down, wait at least 1 minute, 60 seconds. If unsuccessful, repeat up to 3 times. This is basically first step. First time you are doing this, again the process 3 times you do. If unsuccessful after 4 attempts, wait for at least 120 seconds. So, for after 120 seconds, you follow the landing gear gravity procedures, extension by gravity. In all other cases, gravity, whenever like G plus B or B plus Y or any two hydraulic failure, we will be doing the gravity extension. So in all other cases, gravity, gear extension, hand can pull and then turn. Rotate the handle clockwise 3 turns until reaching the mechanical stop, even if resistance is failed. So you have to complete it the complete 3 turns, even if the resistance is failed. Landing gear is down. Landing gear lever should be confirmed in the down position for the following reasons. To extinguish the unlock lights on the landing gear indicator panel, to avoid the landing gear control message on the VLSD badge, to minimize the risk of landing gear retraction on ground due to an unknown system fault when the free fall system is reset. Gear down indication if available. So basically when you are doing gravity extension, all these system has to be. Depending on aircraft speed, the display may show the landing gear doors in the embarked transit position. In the event of gravity extension caused by the failure of both LGCI, indication of the landing gear position on the ECAMs are lost. If both LGCI fails, there will be no indication on the ECAM. Landing gear lights on the landing gear indicator panel remain available if LGCI 1 is electrical. So from the panel we can check if the electrical supply is there. If 3 green down lock arrows are not illuminated, it may indicate that the hand did not reach the mechanical stop. So there is a possibility we have not reached up to the ultimate limit. So check the hand current is firmly against the mechanical stop. If successful, do not reset landing gear extension, landing gear gravity extension. Do not reset the free fall system. And okay, that's all from landing gear. Then the next topic is nose wheel steering. Nose wheel steering, green system to supply start. We were having an old aircraft where it was supplied by green. Now it was because the green system on, even the landing gear is on, nose wheel steering also on, so it's better to it is on the other system, other hydraulic pressure system. So that's why they have isolated it from green to yellow. So a hydraulic actuating cylinder steers the nose wheel. Yellow hydraulic system supplies pressure to the cylinder. And which computer? BSU. ये भी LGCI की तरह होता है या कुछ अलग होता है? थोड़ा सा इसमें चैनल होते हैं या कुछ डिफरेंट? एक ही BSU होता है, 2 चैनल होते हैं या 2 BSU?
1 BSU, 2 channels. 1 BSU, 2 channels.
So unlike LGCI, 2 different LGCIs are there. Whereas BSCU, there are 2 different channels are there. One BSCU is only one, but channels are. So BSCU receive, brake and steering control unit receive orders from either captain or first officer. The nose wheel steering is there, or the rudder pedal is there, or autopilot. All the 3 options. Either the nose wheel steering, or the rudder pedal, or the autopilot. So BSCU transform these orders into nose wheel steering angle. So there is the angle defined. And then the inputs, when you are giving the inputs, there is a limit. You are doing with the nose wheel steering and low speed, then it could be 75 up to 75 degree, whereas with the rudder type it is 60 degree. So the degree is defined, which depends on ground spin and obviously the orders. The steering system receives actuating hydraulic pressure when there is a condition. It will get the information only when anti-skid nozzle steering switch is on. Towing control. Towing control, there is one is tow position, other is normal position. Tow position is for the engine between the ground stop to tow the aircraft. So it has to be normal position, not in towing position. At least one engine is running and aircraft is on ground. For some of the aircraft, there is a procedure of taxi bot. With the help of a machine, will be taxiing it off. So that is a separate class. So where they will explain, there is an external agency will be discussing about the taxi. So there will be a class for Univar also. So a separate class will be there for the taxi. So nose wheel steering. So the steering hand wheels which are interconnected can steer up to 75 degrees. Steering system centers the nose wheel automatically after liftoff. After liftoff, centers. Pressing rudder pedal, this connect push button on either hand wheel removes control of nose wheel steering from the rudder pedals until the button is released. So if you are pressing, so control is gone there. If you release, then it will come. This is the limit. So if you are giving the control from the rudder pedal, so you see plus minus 6, but a high speed there is a possibility we can use less than 6. Whereas with up to 80 knot only, we can use the nose wheel steering, but at taxiing, even we can go up to 75 degrees. This nose wheel steering, while the engineers are doing towing, they can steer up to plus minus 10. Then this is the system. Basically, there are all the three modes we have discussed: nose wheel steering, rudder pedal, autopilot. Here, both the rudder pedals are this nose wheel steering, plus they are algebraically added. Both the information is going to be added. And then the conditions, all the conditions here, anti-skid nose wheel steering switch has to be on, towing position has to be in normal position. So all those conditions has to be met. Then the system, the LO system, LO hydraulic system is there. The LO hydraulic system will start activating in VSCU. This control, every control is there in this computer VSCU. Brake and steering control is there. And then this will be activated and accordingly we can steer the air. PCAM page I am not going to show it. Then there are two memos. This is also sometimes important. Not always, but sometimes. So that you have to remember, green or amber. In green, if you see, nose wheel steering in the towing position, engine is not running. Amber is means engine is running. तो सारे क्वेश्चन ही मिल गए. हो सकता है. Nose wheel steering fault. This alert triggers when the nose wheel steering system is failed. So here, if this fault, nose wheel steering fault is along with the landing gear shock absorber fault, if there is additional landing gear shock absorber fault is also there, then nose wheel may be at maximum deflection, about 90 degrees center. So during landing, delay nose wheel. So basically, it is advised that during landing you maintain. You touch down, means you delay that touchdown. Because already at 90 degrees, then you can veer off from the runway. It is difficult to maintain the control. Automatic rollout is not possible. Sometimes you may require the VSCU reset. So the procedure, VSCU reset procedure they have defined. Unlike the LGCI में lever up down करके हो गया. Here what we are doing, first we have to stop the aircraft, set the parking brake handle to on, confirm the towing bar is disconnected, and then the switch, anti-skid nose will steering switch to off and on. But whenever you are doing these procedures, the logbook entry is must. This is very important because the engineering will come to know, they will analyze what could be the probable reason why you have done, what is the problem. Okay. Now, next and anti-skid. So यहाँ भी ग्लू सिस्टम देता है ना, देखिए क्या मैंने कलर भी इसलिए ब्लू ही किया है क्यों? The main wheels are equipped with the carbon multi-disc brakes, which can be actuated by either of two independent brake systems. So we have two different hydraulic systems. One is green, other is color. Green किसको supply करता है? Normal brake. There is a computer called DSC. Allo जो है वो alternate braking को करता है और वो allo में there is a accumulator also. होता है कि नहीं? Green में होता है allo में. पार्किंग ब्रेक ग्रीन से होता है येलो से? फिर तो पता ही है, फिर तो मेरी कहानी की जरूरत नहीं। So the normal अच्छा है, suppose ग्रीन नहीं काम करता, ग्रीन सिस्टम is not there. Anti-skid, alternate braking with anti-skid is possible or not? Yes. How? So while anti-skid information, BSU, as long as the BSU computer is working, so that anti-skid function will be there. If the BSU is also not working, then alternate braking without anti-skid, only ABCs, alternate braking control. वो भी इम्पोर्टेंट है, इसलिए मैं इस तरह की जो बीच में बातें लाता हूँ वो इम्पोर्टेंट वाली होती है, इसलिए मैं बीच में बोला। ठीक है, वो क्वेश्चन फ्रेम हो सकता है। Normal brake system uses green hydraulic pressure, whereas the alternate system uses the yellow hydraulic system. An anti-skid and auto brake system is also provided. Braking commands come from either the brake pedals or the auto brake. What are the times when we use the max auto brake? कभी यूज करते हैं या नहीं करते? क्यों? So in normal operation, a dual channel BSU controls normal braking and anti-skid. So if everything is working proper, BSU, normal channel, your auto brake will be active, your normal braking will be active, your anti-skid will be active, BSU is controlling that. Now, in case your BSU or green system something failure, so depending upon the failure, braking may be reverted to first one alternate braking with anti-skid. There is a possibility alternate braking. So alternate braking is straight away ABCU will control, but anti-skid will be controlled by BSU. Second case, if now BSU channel is also not, then alternate braking without anti-skid. It means the LO system is there, LO system pressure is available, BSU is not working, G system low pressure. So in that case is alternate braking without anti-skid, only ABC, because alternate braking and LO system. By chance, LO system also low pressure. हो सकता है? फिर तो कोई ब्रेक नहीं काम करेगा, करेगा? So alternate braking without anti-skid on accumulator. So accumulator, now we are using accumulator. So there only alternate braking without anti-skid, which will be controlled by BSU. ABC. लिखा हुआ है वैसे तो। All the normal and alternate braking components are fully monitored. Any detected failure is signaled to the crew via ECAM. BSU performs the following secondary functions: check the residual pressure in the brakes, monitor the brake temperature, provide discrete wheel speed information. Changeover. Unlike LGCI, the changeover between the two BSU channels takes place at each down landing gear lever selection or in case one channel fails. So here two channels are there. They are exchanging. They are switching over one by one. Computer is sending a signal, whereas in LGCI, in the landing gear, there are two different computers. The main gear wheels are fitted with visual flag. Main gear wheels are also fitted with brake cooling fans. Now anti-skid. This is provide maximum braking efficiency by maintaining the wheels at the limit of an inclined. Somewhat important, anti-skid system is deactivated below. पता ही होगा. Then in normal operation, the reference speed is determined by BSU from ADR1 or ADR2 or ADR3. In cases all ADR fails, reference speed equal to the maximum of either main landing gear wheel. No information is coming from any of the ADRs, and whatever the wheel speed is there, that will be the final speed. The purpose of auto brake system is to reduce the braking distance in case of the vertical takeoff, to establish and maintain a selected deceleration rate during landing, thereby improving passenger comfort and reducing burden. So basically only in one case where in takeoff phase we select one max auto brake. Otherwise, some of the cases, some of the failure cases, max manual. When you are doing the calculation yearly also, it will give you information or the auto brake is not available. If the auto brake is not available, the option is max manual. So with the help of max manual braking system, you can get. Brake modes, already discussed normal braking, alternate braking with anti-skid, without anti-skid and parking brake. Braking is normal when green hydraulic pressure is available and the anti-skid and nozzle steering is on. Braking is electrically controlled by BSU from pilot pedal automatically and from the auto brake are applied when the landing gear is available. During normal braking, anti-skid operates and auto brake is available. Normal braking, auto braking. Normal braking is gone, auto braking is on. Auto brake is inoperative. Braking uses the mode when green hydraulic pressure is insufficient or low pressure. LO hydraulic pressure is available. LO is available. Anti-skid switch is on, but parking brake is not on. So here, braking ABCU and anti-skid BSU. Without anti-skid, auto brake and anti-skid are inoperative. So already it is what we discussed. Parking brake. So brakes are supplied by the LO hydraulic system or by accumulator pressure via the parking brake control valve, which opens allowing full pressure application on the main gear wheels. Accumulator maintains the parking pressure for at least 12 hours. But there are possibilities it can be for lesser period because of the aging of the engine. But the system is not effective. Over a period of time, there is some wear and tear, so possibilities are there. Though they have, when they manufacture the brand new, yes, it will be. If the parking brake is activated and no LO hydraulic or accumulator brake pressure is available, then the normal braking system can be applied via the brake pedals. LO accumulators can be pressurized by pressing the LO electrical arm. ट्रिपल इंडिकेटर ये क्या होता है, कुछ होता है क्या? ये थोड़ा इम्पोर्टेंट है. अभी आगे पेज पे आएंगे तब इम्पोर्टेंट है. ट्रिपल इंडिकेटर ऑन द सेंटर इंस्ट्रूमेंट पैनल indicates that the pressure delivered to the left and right brakes as well as brake accumulator pressure. So basically triple indicator for only green, yellow. Only for the yellow hydraulic system. By chance some residual pressure is there. So what is the procedure? So brake and accumulator pressure. Brake pressure is only indicator when the LO hydraulic system controls the brake. Alternate braking system is activated. Parking brake is applied. This is loss of braking. So this is the QRH item or memory item? That you have to remember. This is the memory item. This is the not going to discuss. Is there the normal procedure? This, so anyway, since it is a memory item, you have to memorize. There is no other option. Irrespective of it is important in question or not, you have to remember. Okay. Residual braking. So in flight, what we have to do, if there is a residual pressure indicator in the triple pressure indicator, if there is some residual pressure, so the procedure the Airbus recommends that you several times press the brake pedal. Press the brake pedal several times, that puts 0 as well. So after 2-3 times or 6 times, it will be reduced to 0. If residual pressure remains, still if it is there, still then they have recommended anti-skid and no-wheel steering to keep on. For landing, select auto brake as medium. The moment you select this auto brake, while landing using medium mode gives immediate priority to normal braking upon landing gear touchdown. When the landing gear touchdown, so it will take over the normal braking, which cancel residual brake ultimately. If auto brake not available, apply braking just after touchdown. There is a possibility of braking accident. This is a bit important. Brakes and anti-skid nose-wheel steering fault or anti-skid nose-wheel steering fault. This alert triggers when there is a loss of normal brake system associated with allow system low pressure, or both BSU channels are failed, or anti-skid nose-wheel steering switches ruptured. So in this case, we have to monitor the pressure, brake pressure too. Monitor brake pressure on the brake pressure indicator. Limit brake pressure to approximately 1000 psi, and at a low ground speed, adjust brake pressure as required. Avoid landing on a runway covered with ice. Usually we are not landing on the runway with ice, cold and dry. One brake swat. Brake swat, this indication will come, or this alert will trigger when the one brake temperature is above 300 degrees. So the alert disappears when the highest brake temperature is below 290. So when it is reducing up to 290, this will go off. And they have defined the procedure, you go through in the form. This one more is config parking brake on. This alert triggers when the parking brake is on and thrust levers are set at takeoff or flex on. So in this case, what they are recommending is check that the parking brake handle is on the off position. If warning stays on, check that the brake pressure is at 0 on the brake pressure indicator. So otherwise it is, if it is not there, that's what the recommendation is there. Sometimes parking brake on config, that problem will come. Even in the brake hot condition, if brake is hot now, take off config test, that is also not possible. Till the time brake is for hot, the take off config test is not there. There are occasions when the pilot says this problem when take off rope, pilot take off rope. So the procedure is nothing there, but just a thought of it in the studio, they wait for some time. Even the ASCOM also says wait for some time. So after some time, it reduces less than 290, so automatically that's what message will go off, then you can proceed. That's all from this statement here. Hydraulics को आते ही होगा सब. ये सही है. इसके लिए मुझे भी पढ़ना पड़ेगा ना पहले.
70 slide 26.